Hello everyone, it's Mr. Allen. Today we're going to talk about solving equations. So now that we know what an equation is, it's appropriate to know how to solve them. And what do we mean by solving an equation? Well, essentially all we mean, if we think back to one of our most basic equations that we talked about in an earlier video, an equation like this, 4 equals 4, where this value is equal to this value. When we solve an equation, we're looking for a variable. In this case, all of these equations have the variable of x. And by solving an equation, I want to find out what value for x, what number does x equal that would make one side of the equation equal the other side. So when I'm solving these equations, I am trying to find out for each of these, what does x equal that would make one side of the equation equal the other side, to make that a true statement such as 4 equals 4, for example. So in order to solve equations, again, we talked about the operations that we can perform on equations. And in this equation, we have the operation of addition being performed on x. In the second example, we have the operation of multiplication. This is 3 times x. And in the last example, we have the operation of raising x to the power of 2. So we can perform these operations on variables. So if we're going to work backwards and try to solve this equation, we need to undo all those operations. We need to get back to the basics of what is x. So in order to undo that, we need to talk about something called the inverse operations. So the inverse operations are those operations that undo previously performed operations, and it's just the opposite. So for example, the opposite of addition is subtraction. So subtraction is the inverse operation for addition. The opposite of of subtraction is addition. The opposite of multiplication is division. The opposite of division is multiplication. The opposite of raising a number to a power is taking the square root of a number, or the cubed root, or the fourth root, or whatever power we're raising that number to. And the opposite of taking a root is raising a number to a power. So I could take a number to the second power, or the third power, whatever I need to do to cancel that out. So those are the inverse operations. Those are just the operations that counteract, that kind of help us work backwards. So if I'm going to solve these 3 examples here, I need to think, what inverse operation am I working here? Well, the original operation I have in this first example is addition. So the opposite of adding 7, the inverse would be subtracting 7. But remember, if I want to keep these equations balanced, if I want to keep this equal, to make this side equal to this side, whatever I do to one, I have to perform that same operation on the other. So if I subtract 7 over here, I also need to subtract 7 from the other side of the equal sign. And now we can solve this. A positive 7 and a negative 7, that equals 0. So now on the left hand of the equal sign, I only have an x left, which is exactly what I want. On the right hand of the equal sign, I have this, 38 minus 7. So I can solve that expression. 38 minus 7 is 31. And now I've solved that equation for x. Going down to our second example, we can see that the operation is multiplication. That's 3 times x. The inverse operation of multiplication is division. So I would divide both sides by 3. 3 divided by 3 is 1. So I have 1x, which again is exactly what I want. 18 divided by 3 is 6. And that equation is solved. And finally, in our last example, I have x squared, the opposite of raising a number to a power. The inverse operation is taking a root. So in this case, I would take the square root of both sides. The square root of x squared is just x, which is what I want. And the square root of 81 is 9. So that's solving 3 simple problems using the inverse operations.